Good afternoon, friends. Today we are going to study about the examples of gearbox. Right? In our previous lecture of the gearbox, we had already studied about different kind of gearbox and different kind of method to construct a gearbox. Right? Also, we had already studied about the ray diagram, structure diagram, how to calculate the number of teeth, and the method of the structural diagram and ray diagram. So today we are going to study the numericals of the gearbox. The numerical is the design a gearbox for a headstock to give 16 speed ranging from 50 rpm to 1600 rpm. The power is supplied by an electric motor of 10 kilowatt running at 1440 rpm through a V belt drive with a speed reduction of 2 gem 1. Find the number of teeth on each gears and percentage variation in speed. Right? So in this example, you have to find the number of teeth on each gear which are used to construct a gearbox and percentage variation in speed at all stages. Right? So first of all, list what is given. Right? So given is the maximum revolutionary speed is 1600 rpm, minimum revolutionary speed is a 50 rpm, and number of and given is the 16 speed ranging. Right? Means the spindles number of spindles is 16. Right? Now what is the equation of phi? Right? So equation of phi is n max divided by n raised to 1 upon z minus 1. Right? In this example, we are using the geometric progression method. Right? So we have to find the zth number of spindle speed. So the equation of zth number of spindle speed is n max divided by n mean raised to 1 upon z minus 1. Right? So put the value n max is a 1600 and n mean is a 50, where z is 16. Means what? This 16th spindle speed we have to find. Right? So the phi is 1.25. Phi is 1.25. So from phi is equal to 1.25, the standard speed are for the 16 speed we can get the first spindle speed is a 50. Right? First spindle speed is a 50. Then you have to take the geometric progression ratio. You have to take the geometric progression ratio. Why? Because the geometric progression method, the definition says that the difference of two spindle consecutive spindle speed, but which difference? The reciprocal difference. Right? Means the ratio of this spindle speed are constant, and the ratio of the spindle speed is going to be 1.25. Right? So first spindle is 50, so second the speed of the second spindle speed is 63, then 80, 100, 125. We have to take all this consecutive speed as the ratio between two consecutive spindle speed is constant as 1.25. Right? Or you can calculate as multiplying the previous spindle speed. As the first spindle speed is a 50, then second spindle speed is 50 into 10, 1.25, so we can get a 63. Next 63 multiply with 1.25, so we can get 80. Next 80 into 1.25, so we can get 100. After 100 multiply with 1.25, 125. Right? So consecutively we can find the 160, 200, 250, 315, 400, 500, 630, 800, 1000, 1250 and 1600 rpm. Right? So these are all the speeds, spindle speeds at all spindle. Right? Now we have to construct a structural diagram. Right? We have to construct a structural diagram. So first see the example. What is the given? Given is the design of a gearbox for a headstock to give 16 speeds ranging from 50 to 1600 rpm. Right? Also, and we are calculate the 16 spindle speed. The power is supplied an electric motor of 10 kilowatt running at 1440 rpm through a wheel belt drive with a speed reduction of 2 gem 1. Right now, the speed reduction is 2 gem 1. So, what is the relation between 16 spindle speed to the speed reduction is 2 raised to 4. So we have to construct a structural diagram having a 4 stages, right? So here the z is equal to 16 as 2 into 2 into 2 into 2. So we can construct a structural diagram as we have to reduce the speed as 2 gem 1, right? So p1 is equal to p2 is equal to p3 is equal to p4 is equal to 2, means the 4 stage having the equal reduction ratio is 2. Hence x1 is equal to 1, where x2 is equal to p1 which is a 2, x3 is equal to p1 into p2 is equal to 4, and x3 is equal to p1 p2 p3 is equal to 8. So the structural formula is as written 2 gem 1, 2 gem 2, 2 gem 4 and 2 gem 8. So we can draw a structural diagram. Hence in first stage, here in the first stage we have only a one spindle which is connected to two spindle, right? So the speed is reduced as 2 gem 1. Another two spindle is connected to the 4 spindle, right? And 4 are connected with the 8, and 8 are connected with the 16 spindle. So all the stages having 2 gem 1 spindle speed ratio, and we can draw the structural diagram as per shown in figure. Now we have to draw the speed chart. Here the power is supplied to the input shaft through a belt drive. So the speed of the input shaft is speed of the motor divided by speed ratio, right? So what is the speed of the input shaft is 1440 and the speed ratio is taken as a 2. So it is a 720 rpm. So the speed of the input shaft is 720 rpm, right? So first in the speed chart, this is the shaft motor, right? So its speed is 1440 rpm. Now it is connected to this input shaft and the speed reduction ratio is a 2. So we have to take a point at a 720 rpm. We have to take a point at 720 rpm. Then as per our structural diagram, we have to draw a speed chart, as we can take two speeds. One is the 315 and second is the 250. Then another 250 speed is we have to connect at 315 and 200. Also we have to connect with 315 and 125, and last we have to connect at 315 and 50, right? How can we find all the speeds, right? So we had already calculated the speed. We had already calculated the all speeds, intermediate speeds, which are 50, 63, 80, 100, 125, 160, 200, 250, 315, right? So after drawing after drawing the first shaft speed 1440 and the speed ratio reduction speed ratio 2, so the input shaft is 720, right? This is the directly drawn with the help of the equation, but this speed is connect at the 315 and 250 as per our intermediate speed, and the 250 is connect with the 315 and 200 with the help of the intermediate speed. Also this speed is connected with the intermediate speed, and last the 50 speed and 315 speed is connected with the intermediate speed, right? So the speed chart is drawn as first is the 1440 to the 720. 720 is connected with the 315 to the 250. Then another two spindles are connected with 4 speeds, right? As how you can draw the 4 speeds, let's explain. This speed is a 250, right? So we have to multiply 250 with the 1.25. Whatever value you get, you have to connect with that. and another value you have to divide by 125, then second is connected here. So 250 is connect with the 200 and 250 is connect with the 315. Both the value 315, the ratio between 250 and 315 is 1.25, and the ratio of the 250 and 200 is also 1.25. So आप कनेक्ट, आपको ये जो पॉइंट है 250 उसको किसके साथ कनेक्ट करना है, एक 1.25 से मल्टीप्लाई करने के बाद जो पॉइंट मिलता है वहां पे आपको मल्टीप्लाई करना है, कनेक्ट करना है, और दूसरा 1.25 से डिवाइड करने के बाद आपको जो पॉइंट मिलेगा उसके साथ कनेक्ट करना है. ठीक है. सेम मेथड again, you have 315, right? This point is 315. So first you have to multiply with 315 by 1.25, connect that point, then divide by 1.25, whatever value you get, connect with that point, right? So you got 4 point. Another further, if you are multiply and divide by 1.25 with this all 4 point, you can get 8 another point. If you are multiplying and divide by 1.25 with this 8 point, you can get 16 another point, and all the points are the speeds of the spindle. So this is the speed chart, right? Understood? How can we draw the speed chart? Next, determination of number of teeth on the gear. How can we find the number of teeth? Our question in the example, our main objective is to find the number of teeth at all the gears. So between shaft 1 and 2, the 315 divided by 720 is equal to 1.1 divided by 2.285, right? So is equal to 21 divided by 40, 22 divided by 48 is equal to Z1 divided by Z1 dash, right? So the Z1 is equal to 22 and Z1 dash is equal to 48. So hence Z1 plus Z1 dash is equal to 70, right? This is the equation we have, like, right? So Z1 is equal to 22 and Z1 dash is equal to 48. How? So first shaft and second shaft, right? No. Why? Because this shaft is a motor shaft, so we are not taking into account. So first shaft is here, which is the speed is 720. Second shaft is here, which has a speed of 315 and 250. So we had already taken 350 and 720. Now we are going to take 250 and 720. So we can get the Z2 is equal to 18 and Z2 dash is equal to 52, and both the summation of the Z2 and Z2 dash is 70, right?